Morning, how's everyone doing? And thank you so much for that introduction. And I'm really, just before Tristan goes, I'm really glad to see we will both be talking about similar points, but in a slightly different angle. But then it's really good to see the joint effort across industry. But yeah, here's my talk, What Makes Software Green? As introduced, my name is Sarah Hsu. I'm a site reliability engineer working for Goldman Sachs. I hope you don't read my tag. I spelled it Goldman Sachs this morning. And I'm originally from Taiwan, but I've been living in the UK for about 15 years now. Remember the mic. I sort of wear two hats. I'm an SRE for GS. I'm also the point of contact for GS for the Green Software Foundation, as well as the project chair for the Principles Project. And I'm here today because I want to share my aha moment when I first discovered green software a couple of years ago, specifically how simple and powerful the principles of green software are and how connected they are with some of the best practices we're already doing for other areas such as performance or cost. And I hope that by the end of this talk, you also have your aha moment with green software. So the agenda for today, well, this introduction, and we will move on to the principles of green software, specifically the actions that make software green. And if we have time, I would love to talk to you a little bit about the Green Software Foundation itself, who we are, how we work, and some of the exciting projects that we have got going on. So, what makes software green? We define green software as software that emits the least amount of greenhouse gases, aka carbon possible. There are three actions that can make that happen. Firstly, we can be efficient with energy. Secondly, we can be efficient with hardware. And finally, we can make our software carbon aware. Those actions make software green because they can help us reduce the carbon emissions of our software. And we can sort of group energy efficiency and hardware efficiency together. That's because both categories can be considered as a proxy for carbon. And being efficient with one of them, or both of them, will lead us to be more efficient with carbon. So why is hardware a proxy for carbon? Every object we come across in our daily lives, that includes our mobile phones, servers in data centers, or the materials that was used to build this space, they all emit carbon during the creation and destruction of the said object. And we call this the embodied carbon of an object. This is a really, really important concept to bear in mind because people usually don't realize they need to include the embodied carbon of hardware when calculating a software's total carbon emission. There are two broad categories for achieving hardware efficiency. For applications in the end-user device, we can think of ways to extend the lifespan of hardware. For applications in the cloud, we can look into increased hardware utilization. As you can see on the slide and what Tristan mentioned earlier, for most end-user devices, the embodied carbon is much, much more significant than the lifetime emission from its electricity consumption. So the strategy of extending the lifespan of hardware is probably of most interest to people building software in the end-user space. And one way to achieve this extension is to ensure that applications that you're building also perform well enough in older models. So we're not throwing away perfectly good models just because software have made them obsolete. We can think about it this way. If your device has 1,000 kilograms of embodied carbon and the expected lifespan is 2 years, then that's about 500 kilograms per year. Can you extend a lifespan from 2 years to 3 years just by 1 year? Then the embodied carbon would be about 333 kilograms per year. Let's look at another example. If we have 5 servers, each running at 20% utilization, then the total embodied carbon would be 5,000 kilograms. Or can we have one server running at 100% utilization, so the total embodied carbon would be 1,000 kilograms. So for applications in the cloud, like being private, public, or hybrid, we should look for ways to increase the hardware utilization so we can be more efficient with embodied carbon. However, it's normally misunderstood that our application is straight away more sustainable because we choose to host it in a public cloud. The choice of public cloud doesn't make our software more sustainable, you need to make sure you redesign your software, architect it in a suitable way for the chosen public cloud. So going back to what we previously mentioned, our goal is to reduce the carbon emissions of our software. And we can achieve this goal by making our software carbon aware or carbon efficient. And one way to achieve carbon efficiency in software is to be efficient with hardware, because we can think of hardware as a proxy for carbon. We can also think of electricity as a proxy for carbon. To this day, electricity production is still the single biggest emitter of carbon. And that's because most of electricity, maybe not France, is still produced through the burning of fossil fuels. So if our goal is carbon efficient, then our goal should also be energy efficient. The data center industry has a concept called power usage effectiveness. PUE tells us how efficient a data center is with its energy. It was developed by Green Grid in 2006. Specifically, PUE tells us how much energy coming from the grid goes to the server itself and how much goes to cooling and other overhead activities. When a data center's PUE is 1, that means for every kilowatt hour of energy comes in, all of that goes to do something useful, supporting our applications. But when PUE increases to 2, that means for every 2 kilowatt hour of electricity comes in, one is used for computing and the other is used for overhead activities. Another way we can think of PUE is as a multiplier for an application's energy consumption. It's a way for us software engineers to conceptualize how much energy is needed to support our applications in a particular data center. So for example, if our application consumes 10 kilowatt hour and the PUE of data center is 1.5, then the actual consumption we need from the grid is actually 15 kilowatt hour, where 10 kilowatt hour will go to the servers that are running our applications, and 5 will go towards the overhead activities. Similar to PUE, there's a concept called energy proportionality. Energy proportionality is about the relationship between electricity consumed by hardware and its utilization. We can think of utilization as how busy something is. And if you were like me, you probably assume the relationship between the two quantities is linear and it goes through 0. But that's far, far, far from the case. When computers are not doing anything, they're just sitting idle on our desks, they still consume electricity, and we call this the static power draw of a device, and they can be quite significant. As shown by the graph, as our servers get more utilized, they actually get better at converting electricity to do something useful. I hope this concept further demonstrated how the usage of electricity is tightly coupled to the carbon emitted by our software. So to recap, similar to hardware, we can think of electricity as a proxy for carbon. So if our goal is to be carbon efficient, then our goal should also be energy efficient. And the principle of green software encourages us just to do that. We should aim to waste as little energy as possible, starting from the energy grid to the data centers, but not to the overhead activities, and finally to our end users. Most of us probably think electricity is clean, because when we need electricity, we plug our devices into the wall sockets, our hands don't get dirty, and there's no smell. And for most of us, we have little to no choice on how our electricity is produced. We get what's given to us by our providers. So we have this concept called carbon intensity to measure how clean or dirty our electricity is. The carbon intensity of electricity measures how much carbon is emitted per kilowatt hour of electricity consumed. Carbon intensity changes by location because some regions have better access to clean energy resources. For example, the UK or Taiwan is a much better position geologically to have wind farms, or France is famous for nuclear powers. Carbon intensity also changes over time because we don't get to control the weather. So when it's cloudy or the wind isn't blowing, carbon intensity increases because most of the electricity we get from our providers will be from the burning of fossil fuels. So doing more in your software when carbon intensity is low and doing less when carbon intensity is high is what we call carbon-aware computing. there's a huge, huge traction for carbon-aware computing at the moment, and it's just not just driven by the Green Software Foundation, but by various cloud providers and their consumers. A good and straightforward example of carbon-aware computing is, have you thought about shifting your batch job to a time when electricity is the cleanest? How about your workload? Can you shift your workload to a location where electricity is cleanest? But how about demand? Supply has to always meet demand, right? As mentioned, demand shifting is moving a workload to a different region or time when the carbon intensity is low. Demand shaping is a similar strategy, but instead of moving demand to a different region or time, we shape our computation to match the existing clean energy supply. And we can probably do this for an application that makes video calls. For a video calling application, our voice is normally more important than the visual. So when carbon intensity is high, we should prioritize audio over visual so people can still have a conversation. Basically, what we're trying to do is to shape the demand to match clean energy supply. And this is probably my favorite slide of all time. So if anyone wants a copy or take a quick photo, I'll pause for 1 second. So to recap, we define green software as software that emits the least amount of greenhouse gases possible. We can either make our software carbon aware or carbon efficient. And there are two ways to achieve carbon efficiency in software. And the two ways are being efficient with energy or hardware, because we can think of both concepts as a proxy for carbon. And why is sustainability in tech such a huge topic right now? It's not just because the cloud actually has a bigger carbon footprint than the airline industry. No, it's because software is only going to get more integrated with our society. But it's how difficult it is to implement the net zero strategy so we can limit the global warming to roughly 1.5 degrees Celsius. Net zero strategy is so hard to improve and implement. It's because it demands 90% of the carbon reduction through elimination. And why is elimination so difficult? Let me give you an analogy. If you were to drive a car from A to B, and you choose a compensation strategy to reduce the carbon emission, basically you need to find someone not to drive, so you get to drive. And if you choose the neutralization strategy, that means you need to find methods or projects that will take away the carbon emitted from you driving the car from A to B. And finally, if you choose the elimination strategy, what that means is nobody gets to drive, including you, because we can't emit any carbon into the atmosphere whatsoever. And I hope this strategy and everything that Tristan mentioned earlier reiterates how difficult achieving a net zero strategy is, because net zero strategy demands 90% of reduction through elimination and not offsets. Here are all the principles of green software. I do encourage you to check them out, as they form a core set of competencies for anyone in tech to utilize so we can define, run, and build greener applications. The original principles were written in 2019, but the field has evolved significantly since then. We've been revising and extending the principle of green software since January this year. I'm very, very excited to share we just published the latest iteration during COP27. We've also been working with the Linux Foundation to turn the latest iteration of Principle of Green Software into a training material. And I'm pleased to share the launch of Green Software for Practitioner course. It's free. Yes, you heard it right. The course is a self-paced, free material that can be utilized by anyone in the business of building software. The course itself is split into different modules. Each module reflects one principle of green software. At the end of each module, there's a knowledge check for you to ensure you've gained the correct understanding before moving on to the next module. Right at the end of the course, there's a final exam of multiple choice questions. And if you pass, which I'm sure you will get a certification of completion from the Linux Foundation. Ta-da! And here's my certification of completion. Thank you for that clap, but I don't know whether you will clap to realize I actually wrote the quiz myself. So why are those milestones important to you or your company? As most of us here have experienced, the most significant bottleneck to adopting green software practices is the lack of knowledge. We didn't have a shared language or standardized terminology to carry out sufficient discussion as a community. We desperately needed a unified entry point for software practitioners to kickstart the green software journey. So I want to share this slide. So we have talked about what green software is and why you and your company care about green software beyond the obvious global warming urgency and the open water and climate benefits, right? I'm probably a great example of this particular study. 64% of millennials consider a company's social and environmental commitments when deciding where they want to work. And 88% of them say their job is more fulfilling when they are provided with opportunities to make a positive impact on social or environmental issues. And I have absolutely no doubt those figures will be much higher for Gen Z. So before I wrap up, I want to quickly share with you what the Green Software Foundation is and some of the exciting projects that we got going on. So Green Software Foundation is a non-profit foundation underneath the Linux Foundation umbrella. We're separate legal entities, but we get a lot of help, direction, and predefined processes from the Linux Foundation. Our mission is to change how we build software so there are no harmful environmental effects. The foundation was formed in May 2021 with 8 member organizations, including Goldman Sachs. As of December 2022, we have 38 member organizations, including non-profits, for-profits, and academia. And one of the exciting projects we have got going on right now is the State of Green Software Survey. So could I ask each and single one of you head over to that website listed on the slide so you can take part in our first ever State of Green Software Survey. Your valuable feedback and answer will greatly contribute to our ongoing effort to make software part of a climate solution. Right, so I hope you found the talk useful and you now have enough to kickstart your green software journey. And you have also realized the close connections between the principles of green software and other best practices we're already doing in other software disciplines, such as performance, reliability, or cost. Thank you.